3.3 Rules for Differentiation, Part 1. Your objective for this lesson is to apply rules for differentiation. There are quite a few rules here. Try not to get overwhelmed by them. Oh, where's rule 1? Rule 1. The derivative of a constant function. If f is the function with the constant value c, then the derivative of that function is equal to 0. So, for instance, if I wanted to take the derivative of like y equals 6, that equals 0. Rule 2. Power rule for positive integer powers of x. So this is positive integer powers of x. You'll have a negative one later. If n is a positive integer, then the derivative of x to the n is equal to n times x to the n minus 1. An example of this would be, okay, let's take d dx of x cubed. This is equal to 3x squared. So you take this power down to the front, okay, that's where the 3 came from, and then you drop it down a power. It's a good shortcut. Rule 3, the constant multiple rule. If u is a differentiable function of x and c is a constant, then d dx of cu equals c times du dx. An example of this would be if we take d dx of 7x to the 4th, this is the constant out in front, the 7. This is equal to 7 times the derivative of this, so 4x cubed. This is using rule number 2. Okay, and then you can simplify this, 28x cubed. Rule 4, the sum and difference rule. If u and v are differentiable functions of x, then their sum and difference are differentiable at every point where u and v are differentiable. So at every point where u and v are differentiable. At such points, d dx of u plus or minus v is du dx plus minus dv dx. So depending on if you're adding or subtracting, obviously. So an example of this, we have d dx of 3x plus 4x squared. This would be equal to d dx of 3x plus d dx of 4x squared. So here we end up with a 3 plus, this is 8x. Okay, so this would be your answer. Okay, example 1. Find dp dt if p equals t cubed plus 6t squared minus 5/3 t plus 16. So we're going to use some different rules here. So I'm going to break this down. I have dp dt equals d dt of d cubed plus d dt of 6t squared minus d dt of 5/3 t plus d dt of 16. So I'm really taking or finding the derivative of each individual term here. Okay, this first one I know that I can use my second rule, so the power rule. I'm going to bring down the 3t and drop it down 1, so that's a 2. Plus, I'm going to bring this 2 down in front. Okay, so 6 times 2t, and that's going to be to the first, minus 5/3 times, if I have t to the first here, I bring down the 1 and I have t to the 0. Really, that just goes away because anything to the 0 power is 1. Plus, I need the derivative of a constant, and that is just the constant number. So if we clean this up a little bit, we have 3t squared plus 12t. Oh, sorry, this isn't a constant. That's 0. So 0, there we go, minus 5/3. This is your derivative. Example 2. Does the curve y equals x to the 4th minus 2x squared plus 2 have any horizontal tangents? If so, where? Okay, so a horizontal tangent is going to be any place where dy dx, so the slope of the line, is equal to 0. Slope of the tangent line is equal to 0. dy dx equals 0. The first thing we need to do here is find dy dx. So dy dx of, or sorry, dy dx is equal to d dx of x to the 4th minus 2x squared plus 2. And this, I'm going to just do in one big step here. I'm going to bring the 4 in front, drop my power down by 1, minus 2 times, bring the 2 down, and then that becomes x to the 1st, plus derivative of a constant is 0. So we're left with 4x cubed minus 4x. This is dy dx. Now we need to know when dy dx equals 0. So we're going to set this part equal to 0. Let me do this in a different color. So 4x cubed minus 4x equals 0. I'm going to factor out 4x because I see that that is common to both. And now I notice this difference of squares here. So I have 4x. I'm going to factor the difference of squares. This is x plus 1, x minus 1 equals 0. And I will have a 0 where each of these is equal to 0. So 4x equals 0, x plus 1 equals 0, x minus 1 equals 0. So solving, I get x is 0, x is negative 1, or x is positive 1. Okay? So these are my horizontal tangent lines, basically. Yes. but I want to know the points, so I'm going to go back and plug in to that original function. If I plug in 0 to x to the fourth minus 2x squared plus 2, I'll have 0 minus 0 plus 2, so that's a 2. So at 0, 2, that's 1. And then I'm going to have for this one, I'll have a negative 1 to the fourth minus 2 times negative 1 squared plus 2. So this is 1 minus 2 plus 2. So that's a 1. So I have another one at negative 1, 1. And then last, I'll plug in a positive 1 here. So I get 1 minus 2 plus 2, which is another 1. Okay. So, and 1, 1. So this is my answer. Okay. Rule 5, the product rule. The product of two differentiable functions, u and v, is differentiable, and d dx of u times v is equal to u dv dx plus v du dx. Example 3. Find f prime of x if f of x equals x squared plus 1, x cubed plus 3. So in our product rule, this would be the u, and this is the v. And remember, product rule tells us d dx of uv equals u dv dx plus v du dx. So f prime of x is d dx, this is an x, not a squiggle, d dx of this original function which is our u first, so u is x squared plus 1 times dv dx. So I need to find the derivative of this, drop down the 3, lower the power. This is plus 0 technically, I don't have to write that. Plus v is x cubed plus 3. Du dx is 2x to the first plus 0. Technically, I'm just going to write it like this. Okay. All I need to do now is multiply this out. I'm going to distribute these terms in. So I have 3x to the fourth. Remember, when you multiply variables, you add their exponents, plus 3x squared plus 2x to the fourth plus 6x. I see I don't have anyone with the same exponent, so I'm just going to, or do I? Oh, I do. Here and here. So I'm going to add those together. I'm also going to write this in standard form. So 3x, wait, oh gosh. Standard form means the lowest exponent goes first. So 6x goes first, then 3x squared, then 5x to the fourth, and this is our answer. One more example for this video. Let y equals uv be the product of the functions u and v. find y prime of 2 if u of 2 is 3, u prime of 2 is -4, v of 2 is 1, and v prime of 2 is 2. So remember your product rule. It says that y prime is equal to uv prime. Remember, prime is the same as the ddx's you've been seeing. And this is uv prime plus vu prime. Okay. So this means that y prime of 2 equals u of 2 times v prime of 2 plus v of 2 times u prime of 2. And now we just have to plug in. So we have 3 times 2 plus 1 times -4. Okay, so this is 6 minus 4, which gives us a 2. Pretty straightforward. That is the end of 3.3 part 1.